Let's get started. So we have folks from all over the world, as I just stated. Welcome to our webinar on overcoming the challenges of data management and deployment for manufacturers. We will be reviewing research that we have not yet shared with the market. And as a housekeeping, during the webinar, please type your questions into the Q&A section of Zoom, and we will have time at the end to answer any questions that come up during the webinar. My name is Jared Thane. I will be hosting this webinar, and by way of quick introduction, I lead new sales for FairCom. Joining me are our three expert edge panelists, Andy Joseph, Mike Bowers, and Sanjay Bhatia. I will introduce them in greater detail shortly. FairCom is a global technology company specializing in databases and data management. We help manufacturers extract, connect, and transform their data to optimize processes and real-time decision-making. We provide technology for many of the largest companies in the world, as well as small and medium-sized companies across all verticals and industries. Promise is a global manufacturer of motion control solutions for assembly and test, and is headquartered in Brighton, Michigan, with support offices in Germany, Canada, Mexico, Brazil, and China. With their decades of application engineering knowledge and the world's most advanced servo press technology, Promise serves multiple industries, including transportation, off-road equipment, life sciences, defense, energy, and consumer goods. For over 20 years, Promise has led the way in providing data management solutions in their products for storing large amounts of part quality information for historical or analytical purposes. So here are the three edge manufacturing experts that we will hear from today. Andy Joseph is the Vice President of Engineering at Promise. He excels at creating better ways to design and program systems for manufacturing. As a lifelong learner, Andy constantly studies the latest technologies and trends in manufacturing and the IT industry. His current intellectual pursuits lie in service-oriented architecture, cloud computing, data analytics, and artificial intelligence. Mike Bowers is the Chief Architect at FairCom. He oversees the company's architecture and product roadmaps, which include high-performance databases, IIoT platforms, and legacy system modernization solutions. He has over 35 years of experience in software development, manufacturing automation, database management, and architecture. He is the author of Pro CSS and HTML design patterns, a member of the Insights Technical Committee, and a frequent speaker at conferences. And last but not least, Sanjay Bhatia is the Director of Product at FairCom. With over 2 decades of experience, Sanjay is a seasoned professional in crafting and steering product roadmaps and employing software applications to address intricate business challenges. Sanjay is a passionate advocate for the role of industrial IoT. He firmly believes in its potential to elevate manufacturing companies to new heights of productivity, efficiency, and return on investment. So let's get started. And Sanjay, I want you to help us here. We went and collected information from over 340 professionals that are heavily involved in Industry 4.0. And I'll turn the time over to you to share how we collect that data and any insights that you gleaned from that.
Yeah, thanks a lot, and welcome everyone. And nice introduction, Jared. So as you mentioned, we conducted 3 different surveys, and the survey was like in multiple forms. We sent out an email to OT engineers within manufacturing executives, and other Industry 4.0 leaders. We also attended few industry shows like Automate in 2023 and IoT World Congress in Barcelona, where we asked participants about like what are their challenges with the manufacturing automation, what's their challenges with Industry 4.0, and then we consolidated all this data to present to you. And one of the reasons we wanted to do this survey was because we want to be focused on the market need and what the customers are needing, and so that we can steer our products with the response from the market. So that was the reason we collected this survey results, and I'm happy to present it here. Yeah, let's go to the next question. Yeah, so first of all, like the first question that we asked them was like, how do you move data to the cloud? We are aware that with the advent of IoT technology, and especially in the industry, there is a lot of data being collected. Okay, so we wanted to find out what's the way that industry is tackling that data, and we found that there are multiple ways. The edge computing was gaining traction, which is different from the cloud computing, where all the data in the edge computing, all the data is stored near the source of the data, like sensors, machines, and processed on the edge. And then also cloud is gaining traction. So, but most of the companies are wanting to move the data over to the edge. That's what we found. And there are multiple ways to move the data to the cloud from the edge once it is collected. So we found like MQTT, APIs, JSON is big in transfer of the data. So let's go over to see like what we found, like what are the primary ways that the data is being gathered and moved to the cloud. So Jared, yeah. So 27% edge computing is used with no cloud integration. All of the data is being collected on the edge and processed there. The advantages are network bandwidth, right? I mean, not moving the data to the cloud is giving advantage in terms of like network bandwidth, low latency. There is need for processing the data in the real time and real time analysis of the data, which can be achieved with edge computing. Those who are sending the data are using MQTT to send the data over to the cloud. And that's what we focused on, like top two to build our products. And then there are other ways, like some companies are using IoT platform as a platform on the cloud. And then IT engineers are pulling data using APIs and SQL to process the data. And then there are IoT platform connectors. So, I mean, this is what I found. Mike and Andy, do you want to add a few things here?
Yeah, sure. I mean, I can totally agree with that result because we often encounter systems with our customers that are, let's call them homegrown systems, where they want to store data into oftentimes SQL databases. And they've developed those into entire enterprise applications. So that's a challenge because as you add new equipment to the floor, you got to deal with how do you get the information out of that new equipment. And so we've been involved in several instances where we've had to adapt our data to these homegrown systems.
Yeah.
And at FairCom, starting over 5 years ago, customers were coming to us and asking, how can we collect data locally in the factory floor? And so we know we can get it. So we don't have any network issues stopping us from gathering the data. We don't have any performance issues. But then how can we take that data we've collected locally and get it to the cloud reliably? And that's where MQTT comes in because it's designed to guarantee delivery, even if the target is down, even if the cloud is unavailable or the network to the cloud is down, or every cloud service has an MQTT service to receive data. Even if that MQTT service is down, how can you guarantee delivery? And that's what MQTT does. So we designed into the Edge platform the ability to collect data locally and push it to the cloud using MQTT and other protocols as well.
Yeah. And another factor which is important is the cost of processing the data, right? I mean, if all the data is sent over to the cloud and processed on the cloud, the cost could become like significant. And not all data needs to go to the cloud. Most of the data is needed right on the edge, so that once you have taken the decision, that data does not need to be available in the cloud. So send only that data to the cloud, which is important for, say, like historical analytics. But if you want real-time analytics, edge is the way to go. And that's what we have been finding from the market. And I mean, yeah, that's how I see it. Like
Well,
edge approach to the cloud, like send only the data which is needed and process most of the data on the edge.
We have
Yeah.
customers coming to us all the time saying we're pushing data to the cloud. It's taking too long to get there. It takes a second typically to get data from an on-premise to the cloud, depending on how close you are to the cloud's infrastructure. But that's a long time. If you're trying to do real-time processing in the factory. And especially if it doesn't make it to the cloud or problems prevent it from getting there. But so what we do is we want, just like you said, Sanjay, customers are asking us to process locally, get the data, get it locally, actually transform it, react to it, do things with it, and push it around the factory locally, and then deliver it to the cloud for machine learning, analytics, warehousing, that kind of thing.
I mean, to add to it, like recently, like 2 weeks ago, like I was discussing like one of the use cases with one of the like carbon fiber manufacturer, and they were talking about like how they used to send the quality data over to the cloud for like understanding whether the carbon fibers rolls that they were creating has no defect. And by the time the results were coming back, they had already rolled the carbon fibers and they had to discard the complete roll. And that's where they moved to the edge so that the decision could be like real time and they could stop the assembly line and then discard only the part of the carbon fiber which is bad and continue with the rolling process. So I mean there are a lot of cost savings there as well. Yeah, so yeah, we can move to the next.
That sounds great. Yeah, Mike, why don't you start us off on the next question, which is around programming languages?
Yeah, so we asked our customers and people in the survey to answer the question, which programming language do you prefer? We asked that for selfish reasons because we have to support drivers for different languages. We wanted to know what languages they wanted drivers in. As you can see, there's a long list of languages we put on the list. Let's go jump to the solution or the answers people gave us. And what's interesting is we learned it depends on what kind of segment of the market you're in. And by the way, I'm interested if you take the survey right now online, put your favorite programming language in here because I'm a programming language geek. I love languages. So anyway, I'm not programmed in most of these languages myself. The market, for example, if you're a manufacturer, you're going to want an easy programming language because your OT engineers are really good at PLC programming, but not necessarily IT programming languages like these languages. So Python is working out really well on the factory floor. But if you're a manufacturer, you might want something more traditional like C, C++, or one of the newer replacements for that, like Rust or Go. And so it depends on what you're doing. If you're what kind of market segment you're in, what kind of language you want. Another one is here for a solution vendor, you're writing software to run on the edge, like using an IoT platform like FairCom Edge, and then you're going to use that platform to deliver software. You want a Java program, most likely, because a lot of people develop in Java, or they might do Node.js with JavaScript to have a web page application. So I want to turn this time over to Andy to get his thoughts because he's a manufacturer of equipment and see if this kind of analysis that I've done lines up with your thinking.
It's right on target. We've developed a lot of different generations of controllers over the years, and we started off doing it in C++ and C, and nowadays we're doing it in Rust and Go. We even have some legacy C# that we're still working with. So it really boils down to a lot of the legacy behind the software you're developing. But fortunately, with MQTT and with the technologies out there today, a lot of them can handle these different languages pretty easily. One thing I will say is that we're a big fan of no or low code solutions. And we were one of the first ones in the industry to offer that for programming servo presses. And I could definitely see that being a highly preferable approach for, say, manufacturing engineers or folks who they're not coders by day, but they do have a little bit of a sense of how to do it. And so those solutions are going to be really, really important, I think, for them. And in our industry, we're always concerned about how much time our software developers have to spend on application solutions because they're very expensive folks and they're also focused on different problems than, say, our application engineers. So, just in our business, we've tried to provide these low, no code solutions for our own application engineers to make them more productive. So that's definitely a good approach. One thing I'll say too is that libraries are often one of the deciding factors in what language you choose. As an example, if you're doing machine learning, you're probably going to choose Python because there's great libraries out there, like Keras and TensorFlow and PyTorch and all those. So it's definitely very domain specific, and it really depends on what you want to accomplish.
I got to really second your point, Andy, about the low code, because we found the same thing. And so we build our whole Edge product to be configurable by JSON and to do most tasks with simple configuration. So you don't have to write code. It's like filling out a form with JSON. In fact, literally you fill out a form in our user interface and it generates the JSON and configures our product. So low code is, I think we're finally getting there. It's taken my entire career, all the promises of 4GL and all this other stuff. Finally, we're getting to a low code world, and I'm very excited about it.
Yeah, I think we can all agree that the equipment out there is getting more and more sophisticated, but the skill sets are going down, and so you need these kind of approaches to deal with that fundamental problem.
Perfect. Let's move to the next one. It's our largest section around deployment challenges. And Andy, why don't we have you kick us off on this one?
Yeah, excellent. So the question was, what are your organization's top 5 IoT computing deployment challenges? And let's see what the data shows. Okay. Yes, so I definitely have a lot of experience with data collection from machines. So there's a lot of old equipment out there, and it's really a big obstacle for many manufacturers. Just with our equipment, we'll go out and visit customers, and we'll see anywhere from 2 to 3 generations of our own equipment that's still on the floor being used. And many machines are still using older PLCs that just don't have the computation power to do anything fancy. And it's pretty well known that PLCs are expensive. And they're also, it's also hard to find programmers who are available to program them. But getting into a little more of the nuts and bolts of it, a lot of these manufacturing devices don't have a good way to queue data. Okay. They're good at producing snapshots of data that, maybe you can go out and grab, but they don't internally have any way of queuing that up over time, especially in kind of a durable type of way. Why is this important? Well, one of the biggest things we see is the inadvertent shutting down of equipment. So, when we're writing software, we can't write it in a way that assumes, much like a desktop application, that the power is on continuously. We have to write it with the assumption that the power can be turned off at any time. Okay. That has these huge implications for how you queue data. We see this not only on the device, but also between the device and between the edge and the cloud as well. Just right now, I can tell you that all morning long, I've had a shortage. AT&T has a huge shortage right now. And in fact, my cell phone is still without the internet. So we see things like that in the industry as well. Promus has spent a lot of time and work to do this, and I can tell you it's not a trivial thing. And we do it really well. And we actually have on our controllers, we have up to 80 gigabytes of queuing of data, so that if you lose that connection between, our device and the where it's actually going into the historian, we can queue that up to 80 gigabytes worth. So that's really important for us and for our customers. And I gotta say, looking into what FairCom does, they really do an awesome job of it. So other challenges that we face, the durability of data is really important because, industries like automotive, they want to save data for, 10, sometimes 20 years for like part recall, problem analysis, that sort of thing. We also find that life sciences, I met a gentleman a while back. I said, what do you guys do? And he said, well, half of what we do is make medical devices, and the other half is we make documentation for FDA compliance. Okay, so that's, that's a good example right there that you got to think about the durability aspect. High frequency of the data, we store, in the extreme end, we store a part every second. And that's not just a few data points, that's like entire graph force position graphs. So that creates a lot of data. And connectivity issues, we deal probably 75% of our support calls as it relates to data management is connectivity issues. NAT router configurations, IP conflicts, improper cabling. And it's much different than an office environment too, because in the office you have, an internet connection and a LAN connection. On the floor, you don't have things like DHCP. You don't have just the ease of use. Everything is very subnetted. Everything has a dedicated IP address. So we deal with that on a continuous basis, having to fix issues there. So yeah, these are just some of the challenges that we face. I think it's pretty common in the industry. And then lastly, what I'll touch on is data standardization. That's a huge problem, and it's only going to get worse. We got to realize that every manufacturer has a unique data footprint, right? And it's going to be different from an automotive to a medical device manufacturer. There have been some industries that have been able to standardize data, thinking of like MT Connect. I was actually on the technical advisory group for a few years there, and I got to see some really interesting challenges. But we actually, I remember spending like weeks and months just hashing over simple standards that, that you and I could probably sit down and make a decision on in a matter of a couple of days. So it's that kind of thing that you're dealing with in trying to create standards. I believe that there's just fundamental problems with taking, sort of an ontological approach to data. I think that no matter what, you're always going to need the flexibility between the device and the edge, and of course the cloud, to make that happen in every single instance. So that's, again, that's where the need to have a powerful edge solution is really going to be a benefit there.
Yeah.
And yeah.
Yeah, I mean, I would agree to that, like data standardization, right? I mean, we are talking about like older machines with like say Modbus, newer machine with OPCUA and MQTT. How do you process and standardize the data? And that's where like, Mike, I know you are a big proponent of JSON and like we focused on like standardizing the data using JSON, and because that's what we were seeing in the market. So like Mike, like do you want to talk a little bit about our JSON, like why you chose that one? I know there is a big story out there.
Yeah, well, this is really important. Some people call it data unification or standardization. The first step is to choose a protocol, that you can have a standard protocol. And that's been a big problem in the industry, collecting data from all these machines with these proprietary protocols. If you're a Siemens person, you've got the Siemens S7 and Siemens does other protocols. If you're an Allen Bradley, you got Ethernet IP, you've got OPC-UA, and then there's now this new MQTT thing. And then there's even protocols on top of MQTT called like Sparkplug. And these are all Tower of Babel problems. Like there's protocols for everything. And you're trying to build a factory, you're going to pay a programmer a lot of money to go interpret that protocol and get the data out of that binary protocol into something standard. So what we chose to do, and I learned this early in my career, is that if you can standardize on open standards and use the new modern open standards, you'll be much more successful. And MQTT is one of those standards. And the second part, JSON over MQTT is another standard. JSON is an industry standard, and IT has totally accepted JSON. It rules everything now. It completely replaced XML except for documentation systems. And so JSON over MQTT is a foundation, but that's only the foundation. On top of that foundation, you got to standardize what you stick in the MQT, in the JSON. You got to standardize the names of properties, how you structure the JSON. What does temperature mean? Is it Celsius? Is it Fahrenheit? Is it an integer? Is it a double? Is it, or is it a more precise number? you've got a lot of standardization things you can do, and JSON's just the foundation to make it to give you a good start. And the reason why FairCom chose those technologies is because in Industry 4.0, MQTT and JSON have become the foundation. It's almost unquestioned. There'll be a few folks that question it, but the vast majority, everybody's already agreed on those are the future foundation. Now the industry needs to start standardizing what goes in the JSON payload. But what Andy talked about is like, if you create a very strict standard, like the financial industry has several standards for XML, people fight it and they argue with it. And I've been on I'm on an insights committee for SQL. I know what these committees are like. Sometimes I call it poke your eye out meetings where you're just like, oh my gosh, this will never end. Um, it, what you need is a transformation engine that can take the data that's coming off the equipment. Like Promise has, these pieces of equipment that gather tons of information, but the company that uses it may need it in a different format. You've got to be able to transform the equipment manufacturer's standard into the company standard, whatever that is. And it's not possible really to create a universal ontology for every industry and every company. They all have their own. We work with for example, we work with a very large automobile manufacturer, and they have their own standard for all data from all their equipment providers, and you must follow that standard. So we need a transform capability. So that's what we built into the FairCom Edge product. As we're looking at these problems, we built in the ability to collect data using these protocols, get it into JSON, transform it, and then deliver it out to any protocol, because you may want it in MQTT, but maybe you want an OPC UA instead, or maybe you want it in ThingWorks, or you want it going to the cloud, or you want a REST API to push it to REST. Doesn't matter how you need it. You gotta make this universal translation engine that can translate protocols, translate formats, translate everything, so that customers can just get the job done and not have to program all this stuff.
Yeah, thanks, Mike. And I mean, on these 5 items that we got, like there are a lot of question about like real-time monitoring, analytics on the edge, and executing AI ML models on the edge. So I just wanted to take some time and tell in detail what we found. So real-time monitoring, analytics on the edge. I mean, the industry term for this basically is condition monitoring. Okay, where they want to monitor what is the speed of the motor, okay, what's the temperature of the motor, or say frequency or humidity on the floor. So a lot of factor where they are like in real time looking at what's going on and the alerting on any of the anomalies. So it's like simple condition monitoring, simple alerting based on the data, so they can be aware. Okay, so that's what we are talking about in terms of real-time monitoring. But then how does AI ML models help on the edge? Condition monitoring started evolving into predictive maintenance. Rather than knowing when the machine has gone down and then ordering the machine parts to fix the production line, you want to know in advance, like maybe say in 1 week or 2 weeks in advance, or even further, that this machine might go bad. That's where predictive maintenance and anomaly detection using AI ML comes into picture. And I'm sure, Andy, you have seen some examples there, like of how predictive maintenance might be helpful. So
Oh, yes, absolutely.
give some examples there.
Yeah, well, so you talk about predictive maintenance, and it's highly important for certain industries, especially when you get into continuous production, where there's really no space to store work in progress. And let me just give you a quick example. So a while back, I met an executive who works for a large contract bakery in the Midwest. And, they make cookies and crackers that you buy in the store, the big brand name products that you often buy. And he was telling me about, at the time, they were having issues with conveyors breaking down because of motor failures. And you think about a conveyor, why don't you just replace the motor and get it working again? But with them, the big problem is that, when the conveyor breaks down, they're dealing with perishable goods, right? And then they have no place to store this, in the process of this breaking down. So they have to dump all their product, they have to shut down everything. They have to re-sanitize all their equipment. There was just this huge cost around a simple event of a motor breaking down. And so as it turns out, 70 to 80% of motor failures can actually be predicted from current and voltage alone. So, what that means is if you can get that data and put it into an analytics engine or a predictive maintenance system, then you can actually schedule the ordering of replacement motors in advance of such an event and have that on the shelf ready to go so that, you can respond much quicker. And I know many of us have seen a lot of shortages recently with COVID. And I know that we were having like 52-week lead times for motors and servo drives. And there's still an element of that will persist. And I think, that's something to be aware of. So there's definitely some good financial advantages to implementing predictive maintenance, especially, depending on the industry you're in. But when you think about getting into predictive maintenance, it's really a hard sell, and you really have to have a receptive management team, that's willing to take that on. But I think once you can make that, once you make that conviction, it's fairly easy to do with getting that data, and then being able to analyze it. So.
Some great example.
Yeah, perfect. Thank you for sharing that. Let's move to the next question around hardware and platforms. And Sanjay, we're going to go back to you. Quick note to everybody on the webinar: please put any questions that you have in the Q&A, and we can answer those at the end. Sanjay, go ahead and queue up the next one.
Yeah. So, like one of the questions like that keeps coming is, okay, you have great IoT software, but where do I run it? Like edge computing, where do I do this edge computing? Okay, can I just run it on machines or what? Like some customers are asking us to provide like entire like hardware plus software solution so that they can just plug and play and get started. But what we found, like we asked them, like where are they aware, or where are they running their edge computing software? So like we had all these choices, and let's see what like the data says where most of the edge computing and IoT platforms are running. Industrial PCs. I mean, that's what like I am finding. Industrial PCs. I mean, there are IPCs which are very powerful nowadays, where like big IoT platform could be run. But then edge servers, we have edge gateways. Virtual machines are gaining traction. I mean, recently, like we were working with a customer, and they want to do all of it on virtual machine. And then container and appliance come last. I'm seeing more and more appliance getting traction where you have all the security patching, all the containers such as like Dockers all implemented so that the IoT software can be containerized within this hardware, and they just put this appliance there. I mean, that's what I have been finding like from the data, and we are focusing on like IPCs from FairCom's perspective. Yeah. Anything like what are you seeing, like Andy or Mike there?
Well, I wanted to actually, I think any of these hardware platforms work great, and operating systems are moving more to the Linux, and the embedded space. But I wanted to touch on something that Andy mentioned in his in the last discussion that I think was brilliant, and I think it's super important. He used the phrase queuing data, and I think that is absolutely spot on, because it's not about just storing data. And you really, in manufacturing, you really want to collect data as events. These are data collection events, and they're in order. Their order matters. What happened when, because it's very process driven. So processes happen over time, and so you queue things up. And so it's critical that you choose a database that is very friendly to queuing. And what we did is, as an architect, I looked at FairCom and said, what can we do in this edge space to capture this kind of queuing data? So a lot of folks just instantly assume, well, let's get a time series database, because time series is about events over time, right? So that will queue up our data. And that's good. And you need to timestamp your data, and you need to achieve that. But it turns out that time series has a little dirty little secret that people don't know about, is that they are the real secret of time series. They highly compress the data. And in the process, it's really slow insertion rates. So if you really want to get high data collection, time series doesn't do it for you. But the key is really having a flexible database with JSON that is event focused. And that's why at FairCom, we decided to invent a whole new technology. We merged the MQTT broker and a timestamp database together into one technology, so that we have built into our database queuing of data that's time series data. And no matter how the data comes in, it can be sent out with store and forward guaranteed delivery over any protocol. That's a whole new technology that no one else has. And we build that because of what Andy was talking about, the need to gather data in a queuing fashion, as opposed to just time series or just throwing data in a bucket somewhere. And so I had to bring that up. Sorry for going back to the previous set, but Andy, your comment was beautiful about the queuing nature of manufacturing data.
Well, thank you. Looking at this slide, it's revealing in the fact that, and we've done it many years. We've used industrial PCs, and it's revealing in the fact that we kind of have a huge problem on our hands. And I'm taking kind of a contrarian look at this, and that I think this number is actually going to change. PCs, which we commonly associate with the Windows operating systems, they fall under the IT management regime. And with IT, they don't want any USB ports on it. They want to control the Windows version at all times, software updates, antivirus protection. We started several years ago to move away from IPCs, and nowadays we wouldn't even think of developing based on an IPC. In fact, we develop our own electronic hardware, our own embedded systems, and we actually are going with embedded Linux. One of the newest things that we're doing is we're developing our services using a containerized approach. What that means is you're able to take a program written in any language and to be able to run it on an edge hardware alongside any other program that's running potentially different languages. And that gives us a ton of flexibility, but it also increases how we deploy our software and increases the security as well. So we're really excited about that. But definitely, the trend in the industry is towards removing, costly infrastructure like rack servers, whole IT departments in some cases, and even moving things into the cloud, in some cases on-premise cloud computing. These are all definite trends that are happening today. So yeah, it's exciting, but it creates new challenges, I think, for vendors like us.
Yeah, good point.
Yeah, great point. Let's move to the next section on features. And Mike, I'm going to have you kind of jump in and share some thoughts there.
All right. So there's a lot of information on this screen because it's about features and what features do you need. So we put a lot of features on the questions, and you can see features about extracting data, persisting data, pushing data to other systems, integrating with SCADA systems, transforming data, running machine learning on the edge, doing real-time analytics on the edge, pushing data to the cloud, and integrating with MES systems, and of course other things. So let's move to the results and see what people said. And the number one was extracting data, and by actually quite a bit of a margin. And that's because of the cost of paying people like me, which earlier in my career, that's what I would do. I would write these drivers to go do these proprietary protocols and gather the data out of the machines, convert it to some kind of data standard, and deliver it to other systems. And I learned how to do all this when I was in the semiconductor industry, and and I actually wore those bunny suits. If you remember the old Intel commercials, and the people dancing around in the bunny suits in the fabs. So I was one of the guys wearing a bunny suit in the fab, going in there and writing software to collect data. And we used message queues back then to get the data that we collect into a standard format so we can then work with it. And the semiconductor industry has been using message queue technology for 40 years to do that. Other manufacturing companies now, the whole industry is now realizing, well, hey, MQTT exists, messaging is the way to go, because it's all about what Andy was talking about, queuing data. So message queues queue data, and they can push data events, and that's what you need. And so that's what we learned. So we built the whole edge product around this whole idea of low code JSON configuration, so that we can just configure the data collection for you. We automatically convert it from a binary data into JSON, automatically can deliver it to any protocol you need, so that you don't have to pay people like me a lot of money and take a long time to write all the software to make it happen, which increases your risk of failure, because some projects I was on in manufacturing actually failed because of people lost hope that getting that but not binary protocol to work, and the developer wasn't doing a good job. And anyway, so it's a huge problem, and the whole industry 4.0 is about solving that by making these universal translators like FairCom Edge, these IoT platforms that can just take data and get them into standard formats and push them wherever they need to go. And then number two, the data persistence is super huge, because we've got companies coming to us all the time saying we have to collect quality data. And as Andy pointed out, you have to keep, data around for 10, 20 years in automobile industries and other industries that support automobile, particularly in medical is the same thing when you have recalls. And you have to know that this part on this date in this particular machine was manufactured badly, and we need to recall just that much. And you can save millions of dollars by knowing exactly and limit your scope on where the failure is. Well, that means collecting all the data. That means you persist it. So like right now, we're working with, again, a major automobile manufacturer who are wanting to persist the data they're collecting over MQTT into a database for quality. Their challenge is they're sending MQTT messages containing JSON. When they're sending it to an MQTT broker, and most MQTT brokers just take the data and pass it on and forget about it, right? It just grabs it, forward it. That's why they call it middleware. You just pass it to subscribers and you're done with it. Well, they need to know that that data was actually collected, that the data message actually went out, was actually received, and they need to track it. And that's what FairCom Edge does. And no matter how data flows through the system, we persist it. And so we learned that through our surveys, we learned that persisting is super important. And then, of course, pushing data to external enterprise applications like the cloud or a data warehouse is a huge deal. And the IT world needs to get this data. Boy, is it a trouble for IT. They want OT data so bad. We were at the same manufacturer. I've been talking about this automobile manufacturer. We've been working with them for over almost 6 years now. And I remember in one of their meetings in their R&D facility, the director of the facility sent over one of the guys from IT to go talk to us, because the OT engineers that were there ghosted him in the meeting because they didn't want to talk to IT. I'm not even dealing with this IT. He wants data. We're never going to give him our data. In fact, the guys we're working with in OT were telling us, yeah, we never give data to the IT guys. And so the director sent him over to us, and we showed him how, well, yeah, we collect the data and we have protocols for you IT guys, because we have built-in SQL. So your data warehouse guys can just query the data and get it. We have REST, so that your programmers can come and get the data, and then we have MQTT so we can push data to you. So that makes it, the guy was like, really? It's like you're handing me this OT data on a silver platter and all my 3 favorite protocols that IT likes. And so that's really important. So I want to open this up though for Andy. Do you have any comments on what are your most important features?
Yeah, Mike, I mean, we've hit on them pretty much already, but just to reiterate, I would say definitely low latency. You need to be close to the device to get that. Durable data, it's got to all be there, but it's also got to last for a really long time. And then reliability for me are big drivers for edge computing. And we're not seeing all of that in the cloud solutions today. Then one last thing I'd like to touch on is there's a bit of I would call it a stateful aspect to handling manufacturing data. So typically we're involved in several different operations that, for example, if you're putting a transmission together, transmission has a lot of different press operations. And so, each one of those operations is a whole bunch of information by itself, but you've got to be able to combine all that to make it represent, say, a complete part history. And so the information tends to be kind of stateful as to how did this transmission get made, over a period of time. And it's a little bit harder to assimilate that in the cloud without good, data queuing, good data tracking, of course, serialization. All of that is very important, which, is a key element of the edge. So I think that's a great point.
And I mean, you have touched base on most of the items here. What I want to take here is integration with existing SCADA system. We like on calls, we keep getting the question about, should I implement SCADA or IoT platform? Okay. Or if we implement an IoT platform, do I need to replace the SCADA system? And our answer is mostly no. These go like they are complementary to each other. SCADA is mostly for like control of the machines, okay, control of PLCs, whereas IoT platforms are for collection of the data, transforming that data into standardized format, and then making it available for further processing or do the processing. And that's where like I like asked this question, like good IoT platform integrate with existing SCADA system so that you can complement. Yeah, we can move to the next.
Yeah, this is great. So let's cover the last section, and I actually really like this session. I'm interested to hear what they had to say around business outcomes. So, Andy, why don't you kick us off and share what companies are trying to achieve in terms of business outcomes that you're seeing out there?
Yeah, well, a couple of things come to mind. Excuse me. One of them is called, I guess the industry calls it predictive quality. Being able to use data analytics for part quality. And I guess it's becoming a thing. So I think the idea there is you're able to collect data throughout, an entire stream of manufacturing and put that into, data analytics and to be able to predict quality issues before they turn into finished goods. Because we know that as it gets further down the line, it gets more and more expensive to throw away. And they're also using these types of systems for root cause analysis, being able to, okay, we've got a failure here, but what led up to that? That kind of analysis is really important. And then even being able to see things in your processes that you were never able to see before because of, sort of that needle in the haystack type of situation. I know there's some companies out there, for example, Acerta and Eigen Innovations are working hard on those kinds of problems. The other big thing that we're seeing is the notion of reducing power consumption. So, a lot of bigger companies are focusing on sustainability and carbon consumption. And they actually have some top line initiatives that are driving that into the organizations. So let me just kind of preference everything with a trivia question. So is anybody here from Michigan in the audience? So I have a question for you. So who is Michigan's largest consumer of electricity? Well, as it turns out, it's actually a little company, actually not a little company, but they're in the middle of cornfields of central Michigan called Hemlock Semiconductor. And they're probably one of the world's biggest producers of polysilicon. And so not too long ago, they started a grassroots project that they called science-driven power management. Okay, and so they use data from all their operations and their equipment, and they fed it into a product called TIBCO Spotfire, which is a data analytics tool, in order to understand what their power consumption was. And so from that understanding, they were able to build algorithms to better plan their production schedules around the energy rates. So like when residential goes down, their production went up. When residential power needs went up, their production went down. So they were able to balance this out in a way to take advantage of better power rates. And they're actually saving over $300,000 a month on electricity just because of some basic data analytics into their operations. And those are the kinds of, stories we like to hear about when it comes to, data analytics, and they really are powerful in convincing upper management. So.
Thank you.
Mike or Sanjay, do you want to add some commentary here?
Yeah, I mean, the other part is like we have talked about like OT and IT. I mean, what I'm seeing is like to bridge the divide. I mean, there are two plays, right? Like from a company culture perspective, many companies are setting up the manufacturing center of excellence or industry 4.0 excellence center, where they are bringing both OT and IT together to work on a like single solution across the factory, across the IT solution, and removing the silo. And then IIoT platforms can help there, because IIoT platforms can not only understand OT side like Modbus, OPC, UA, Ethernet, IP, but then make life easier for IT teams via JSON, SQL, and other standardized way of transferring the data like MQTT. So I'm seeing a lot of companies like not talking about like OT, IT as separate, but they want to like bring a feeling of uh, a consistent like one team, right? One team, one dream, and take the companies to next level of digital transformation. And IoT platforms such as FairCom Edge can help there. Yeah, I mean that's what I wanted to add.
I
And
think that's a great point, Sanjay. I mean, a lot of companies run into trouble with their projects because they don't take a cohesive view towards the IT area and the OT. And they really are much more successful when they involve both groups at the same time on new initiatives, and they get much better results that way.
that's been my experience too. When I was working in the silicon industry, we had a new CEO came in to the company, and he wanted to get data out of the systems to make decisions. And his answer was, "We'll just replace all the software with a new ERP system, and it'll all work well." And he didn't take into consideration that it's not the software replacing a gigantic system like that. It's the problem. It's actually understanding where the data is flowing and getting value out of the data. And I learned that in my last job when I worked for a large multi-billion-dollar international corporation, and I was the data architect for them. And we had a team of over 100 business intelligence engineers, and their whole job was to go get data out of the thousands, literally thousands of databases of all kinds of flavors: Oracle, SQL Server, NoSQL, et cetera. All those databases had data in transactional form, but in order to answer the business questions, you have to take the data and turn it into answers to questions. So you have to reshape the data to make it to get answers out of the data. And so there's a whole warehousing term called Kimball data methodology for data warehousing. So this idea of in order to make data, get the riches out of the data that's in there, you have to take the data out. You have to transform it, reshape it to give the business the answers they need, so the executives get the data they need to make the decisions. And to me, the number one business outcome is to get the data to the BI engineers or to the executives so they can make decisions. And that requires lots of data to getting the data out. It's called ELT in the data in the IT world. Is extract, transform, and load, or extract, load, and transform, depending on what you're talking about. So you're extracting the data, you're loading it in another system, and you're transforming it so that you can get the business answers you need. Because without that transform part, the data is too hard to answer the questions. So you have to reshape the data. So that is the goal. One of the goals of our FairCom Edge product line is to push the data wherever it needs to go and transform it so that the data arrives in a way that's usable and that the business can make the best use of it and get the value out of it.
Yeah. Thanks, Mike.
Perfect. Thank you. Yeah, so let's move to the Q&A section. And there was a question posed, and I think this is a really good way for us to share some insights here. So On the top 5 deployment challenges, security didn't make the top 5, but it made number 6. And I think that it would be very relevant for us to share some insights around why security is important in terms of, a deployment challenge.
Ransoming data is a big problem out there. Hackers break in and they encrypt your stuff, and then they charge you tens of thousands of dollars to unencrypt it. So you have to have strategies in place to have safe copies of your data, so that if they get one copy encrypted, you have another copy you can immediately go to and stay and keep the factory running. That's just one example of a security strategy. But Andy, you were going to answer that too.
Yeah, no, I mean, that's absolutely correct. I mean, a lot of companies are worried about being held for ransom. One thing that we also see is companies want to make sure that as the data makes its way into analytics, that they're verifying the provenance and the authenticity of the data, right? And so we're seeing a lot of interest right now in digital signing, being able to sign the data before it even gets to the cloud. And in fact, Promus right now is implementing TLS, which is kind of a way to do, it's kind of tied into digital trust and digital signing. And then also companies are worried about third parties accessing process data or design information. Because if you have like a machining center that's producing data about what's happening in the machine, I mean, you could theoretically reverse engineer that and get like GD&T data and stuff like that are really what you need to reproduce those parts. And then, so that is definitely a big concern. And the other thing that we're seeing too is they want to make sure that the devices that are on the plant floor are truly authentic. And that the software running on those devices can be trusted. And so we're having to do some things on our side to be able to make sure of that as well. So it's definitely it's definitely a growing problem that vendors like us are taking seriously.
Yeah, we have to sign all of our executables so that they're official for Microsoft and Apple, and so that you're running an officially signed version of our software. Yeah, it's a big problem.
And I mean, definitely, I agree with all these points. And data security and privacy is one of the reasons that edge computing is gaining traction, because that way, like, companies have more control on their data, right? I mean, they could cut off the edge network from the public network and keep their data secured. Okay, so I mean that's the push for edge computing. That I
The
mean,
other thing I'll add to that too, Sanjay, is that a lot of the devices out there aren't capable of even encrypting data. And so that's where an edge solution allows you to create that, that encryption layer. So
yeah.
And in order to get that encryption layer for data in transit, being over the wire, to do the modern safe technologies, which would be using TLS, transport layer security, you've got to have certificates. And you can't use the public certificate companies to generate certificates for your in-house factories or in-house stuff, because they're meant for the internet. So you need to go create your own certificate authority, or use somebody's software that you purchased to do it. But it turns out we spent at FairCom, we spent a ton of energy and research in building out our own ability to create certificates for you. So we have a certificate authority system where just with some simple scripts, you can generate your own certificate authority. You can generate your service certificates, your client certificates, and you can do it in a secure way with just a few simple command lines, and generate and maintain them over time, because they expire. Then you got to go and run. So you have a whole built-in process for you that it's really simple and easy to manage the certificates part of your solution, because people don't realize you may say, if a vendor says, yeah, we have TLS in transit and at rest when you store data on disk, but they don't provide you with a certificate solution, what good is it? Because if you don't have the ability to create these server certificates, the certificate authority certificates, the client certificates, you can't use it. It doesn't work. So that's why we provided you a full solution that just out of the box, you can create all that stuff. We have tutorials on it. And we realized we had to do that because in the manufacturing world, I'll put it this way, certificates are hard. I don't care if you're an IT person or if you're an OT person, they're hard to understand because there's so much junk over the years being published. There's so many contradictory viewpoints. So we decided to go take the bull by the horns, wrestle it to the ground, and solve the problem for you. So you can just run a few scripts and you're ready to go, and it's proven and it works. So now we've
That's
made it realistic to get the job done.
that's a great note to end on. Thank you to the panelists and thank you for all the attendees. We hope you learned something today. If you didn't get your questions answered, please reach out. We'll also follow up with some information. Thank you. Have a great morning, day, or evening, wherever you are in the world. And thanks again for joining us. Have a great day.